Hey guys, today we're going to go through a couple of practice HSC questions that talk about error and accuracy of measurement. So this is from the 2015 paper. It's question 12. Length of a fish was measured at 49 centimeters. We're asked to find the percentage error. Having a look at the question, the first thing I want to try and identify is what's the limit of reading. In other words, what's the smallest unit of measurement that I can record it to. Now the question tells me it was recorded to the nearest centimeter. So 1 centimeter is my limit of reading. That will allow me to work out my absolute error because absolute error is half of that limit of reading. So I have an absolute error of 0.5, half a centimeter. That is important because now I can put that into my relative error formula, which says, well, the relative error is if I take the absolute error and divide it by the measurement, I will get a value for relative error. So in this case, I take the 0.5, I put it over the original measurement, which was 49, and I get a decimal value of 0.01. Now the last step, and nice and easy, I've got a decimal to convert that to a percentage. I simply multiply that by 100. So if I take my relative error, multiply it by 100, I get an answer of 1 in this case. And so the only option looking at that list there is plus or minus 1%. From the 2014 paper, question 10, it says the top of the Sydney Harbour Bridge is measured 138.4 metres above sea level. Once again, what is the percentage error? So it's going to be a very similar process to the question we just did. In this case, though, I've got to have a look. One difference is, what is my limit of reading? Well, I can see by looking at the measurement that it's down to 0.1 of a metre because it was measured at 138.4. So that, given that measurement, I can see, well, that must be my limit of reading because there's no more accurate value that I've been given. So I take that to get my absolute error. I just halve it, and I've got a absolute error of 0.05 of a metre. Take that now, divide it by the measurement, just like we did in the previous question, and I get a value, a decimal value of 0.00036. All right, so far so good. Just like we did in the last question, all that's left to do to convert that to a percentage is multiply it by 100, and I get 0.036%. The answer being A. One more. This one was not a multiple choice, unlike the previous one. So from 2013, it was broken up into a couple of parts. Couple of little tricks in this one, so let's go through. Part 1. The limit of reading I can see is 1 centimeter because it tells me it was done to the nearest centimeter. Okay, which gives me an absolute error, half of that of half a centimeter. Now, I've got to be careful and read the question because it says calculate the error of measurement on the longer side. So if I have a look at, actually first let's go back to relative error for that. Yeah, now that makes sense, sorry about that. The longest side, okay? I had to find what the longest side was, okay? So I've got to look at the question and I can see that of the two, this one here, the 25 centimeter. So that's the number I'm going to use here in my relative error. So when I put the absolute error over the measurement, I had to make sure I get the right one. 0.02. The question though asks for a percentage error. So take that decimal, convert it to a percentage by multiplying by 100. 2% was the percentage error for the longest side. Now, part 2. Here's something that we haven't seen in the previous questions. It asks for the upper and lower limits of the area of the chopping board. Okay, the area. So that's multiplying them two together. Now, remember from previous work that we said to get an upper and lower limit, you add or subtract the absolute error. So in this case, let's take the smallest possible measurements that chopping board could be. Because the area, the absolute error in this case was half a centimeter. So I take half a centimeter off both my measurements because that's the smallest. The length could be 16.5 by 24.5. Okay, so I've taken half a centimeter off the original measurements we were given. So if I multiply them together, I get an area of 404.25. Let's do the same now, but with the upper limits. So if both measurements had their absolute error added, the largest my measurements could be would be 17.5 and 25.5. And if I multiply those together, I get an area of 446.25. So in other words, the actual area of that board would be somewhere between 404.25 and 446.25, which I didn't write on there. Sorry about that, but you guys know what I'm trying to say. All right, great. Well done.